Hi, this is Maggie. In this video, we're going to continue our conversation about string processing in Java by talking about the StringBuffer class. If you haven't seen the first video on understanding strings and string operations, I'll put a link here and in the description. In our last video, we wrote a search and replace method that used strings, and I mentioned that it wasn't very efficient. Let's dig into that idea for a moment. I've copied that code into a new class called StringBuffer demo. And this class contains the find and replace method that we wrote before, plus a main method that invokes it. I've put a breakpoint at the start of find and replace. So let's run this program in the debugger and see what happens in memory during the find and replace method execution. I'm passing in a string that has 3 occurrences of the string we want to replace, which is Java. Line 4 stores the index of the first occurrence of our search string, Java, in the variable index. We can see that is 0, as Java is the first word in text, our string. Now we loop. On lines 6 and 7, we construct the new string called newText, which is our string text with the occurrence of Java that we found at index 0, replaced with the string all uppercase Java, our replace string. This is a separate string in memory because strings are immutable, meaning they can't be changed. So there's no way to substitute characters into the original string. If we open up the strings in the Variables tab of the pane on the right in the debugger, we can see that text and newText have different IDs, meaning they're different strings in memory. Now on line 8, we assign newText to text. And now we can see the IDs are the same. We search again on line 10 and get an index of 42, the next occurrence of Java in the search string. We step through lines 6 and 7 and construct a new newText string, replacing that second occurrence of Java, and this is a new string in memory, as you can see by the ID. Now we assign that to text. And if we loop through again, it happens one more time. Each time we replace an occurrence in the string, we need to construct a new string, which is then thrown away on the next substitution. So this is inefficient. Let's look at another class in Java called StringBuffer. This is the Oracle documentation, and it describes StringBuffer as a thread-safe, mutable sequence of characters. Like a string, but can be modified. Exactly what we want for this and many other string applications. We can construct a string buffer that is initially empty, or with a string as a parameter, and a few other ways. Let's look at some other methods. We can append many different data types, including numeric types, strings, other string buffer objects, and Unicode code points. We can get the character at a particular index. It has 2 index of methods, like string. It has a delete method and several different insert methods, and it has a replace method. If you have a string processing application, you might like to look through this documentation to see whether StringBuffer already has the methods built in for your application. Finally, notice that you can convert a StringBuffer object to a string using toString. Let's look at replace, because that might be exactly what we need for our application. Replaces the characters in a substring of this sequence with characters in the specified string. The substring begins at the specified start and extends to the character at index end -1 or to the end of the sequence if no such character exists. First, the characters in the substring are removed, and then the specified string is inserted at start. This sequence will be lengthened to accommodate the specified string if necessary. That looks like exactly what we need. Let's rewrite our method with a string buffer rather than a string and see how it works. I'm going to leave the name of the method the same so it will be easy to reuse the JUnit test cases we already wrote. Remember that they found an error in the prior version of this method that we were able to fix. Let's start by creating a string buffer, passing in text as the argument to the constructor. So StringBuffer SB equals new StringBuffer text. And then I'm going to replace text with SB in the 2 index of calls, the one before we start the loop and the one in the loop. Now, within the loop, rather than creating a new string, concatenating pieces together, and assigning back to the old reference, let's try sb.replace. And let's look at the parameters in the documentation. It wants start, the beginning index, inclusive, end, the ending index, exclusive, and str, the string that will replace previous contents. So start is going to be index, and end will be index plus search.length, and str will be replace. Let's rename that parameter to be replace str to avoid confusion, since this method is called replace. And then finally, we want to return sb.toString, as this method returns a string. Let's run our program and print out new text and see if it works on this one example before we test with our JUnit test class. Yes, that works great. I'm going to copy and paste my JUnit test class into a new class called TestSBSearchAndReplace. And now I just need to change all references to string demo to StringBuffer demo. And let's run the tests. And we get the green bar. So efficient, and it has a built-in method that does exactly what we want. What could be better? That is a quick overview of the StringBuffer class and how and why to use it. I hope that it's helpful to you. In the description of this video, there is an auto-graded practice exercise for you, so you can practice writing the method that we wrote here. Give that a try, and maybe read through the StringBuffer documentation and experiment with the class a little bit on your own to see what it can do. Have fun with it.